Alright guys, welcome to Unit 6 Test Study Guide. I'll be going through the even problems for number 2. We're being asked to graph a quadratic equation here in vertex form. The first thing you're going to do is take note of your vertex. That would be these two numbers. Notice that I changed the sign of the 6 though. You do the opposite sign of that number, and that's what makes up your vertex. The next thing that we're going to look at is this number. If it's negative, that means it's going to be a upside down parabola, and if it's positive, it's a right side up parabola. So in this case, we're going with the upside down parabola because it is negative. So a rough sketch of this would have a vertex at 6, negative 2, and it would be an upside down parabola. So it would look something like that. Number 4, sometimes you can be missing numbers. So a quadratic that is in vertex form typically has 3 numbers that we really care about: the A, the H, and the K. But if they're missing, then we have to kind of think about what those values would be. So if there's no A, that would mean that A is 1. If there's no H, that would mean H is 0. And if there's no K, that would mean K is 0. So over here, all right, so in this case, we're missing the A. There's no number in the front, so that would mean it's a 1. We do have the H. It's a 5. But we're missing the K, so that would be a 0. Okay? And so in this case, then, the vertex will be 5, 0. And once again, because that's a negative, we'll have a sad face parabola. So my graph would look something like that. I meant to do number 4, but I did number 3, but that's okay. I'll let you guys check out number 4. Let's go ahead and take a look at number 5 here. They want us to find the y-intercept. The y-intercept is where a function touches the y-axis. So like maybe something like this. Something about the y-intercept is that the x value will always be 0, and then we want to find the y value that goes there. So to do it, we're going to plug 0 in for x and solve for y. Make sure you follow your order of operations here. But for this problem, I end up getting 29. So that would be the y-intercept. That's where it touches the y-axis. You could write your answer like this if you just want to tell me the y value. You can also write it as a point where the x value is 0 with the y value that you found. All right, let's go ahead and move on to the next one. Number 8. All right, use the information provided to write the vertex form of the parabola. So step 1 is to plug things in to this formula here. This being the vertex, this is the H value and this is the K value. For the, this says focus, but you could ignore that. It's just point. The point gives us another random x and y value, and we're just going to plug those in for each of the letters below. So the random y value is negative 24. We don't know what the A is. The random x value is 1. The H value is 3. The K value is negative 8. And then from there, what we're going to do, so that's step 1. Step 2 is to solve for A. So 1 take away 3 is negative 2. Negative 2 to the second power is 4. So I've got a times 4, which I'm just going to write it like this with the 4 in front. Next, we'll add 8 on both sides. And that's going to give me negative 16 is equal to 4a. And then I'm going to divide both sides by 4. And I end up with negative 4. All right, so step 1, plug stuff in. Step 2, solve for a. Step 3 is we're ready to write our final answer. You're going to plug in your a value, and you're going to plug your your h and k into this, and that will be your final answer. So the y stays there. The a was negative 4. The x stays there. The h is 3. The k is 8. And that would be the equation of that parabola. This one says use the information provided below to write the standard form of the equation of the parabola. So this is what's known as vertex form, and I want to change it into this, which is standard form. The first thing that we're going to do is we're going to do this x plus 1 to the second power. Okay. Now I'm going to use our shortcut for that. X plus 1 to the second power means we have x plus 1 times x plus 1. You could use the box method if you want, but I'm going to go with the shortcut. X times x is x squared. 1 times 1 is 1. 1 times x is 1x, but we're going to double that to get the middle number. And so it turns out to be x squared plus 2x plus 1. So we're going to bring down our 2 and our 8, and we're going to replace this x plus 1 squared with what we just got using the shortcut. The next thing that we're going to do is distribute. And then the last thing that we're going to do is combine our like terms. At the very end here, we can put those two together to get 10. And there's the standard form. It's the same equation as this one. So these are the same equation, actually. It's just that they're written in different ways. The top one is vertex form. The bottom one is standard form. Number 12. We want to solve this equation. It says by completing the square. You can ignore that. That's not something we really need to worry about. We just want to solve the equation. So we're going to add 102 on both sides is the first step. What would that be? 96, I think. The next step is to divide both sides by the 6. So we want to get rid of the numbers that are outside the parentheses first. So I added the 102 and divided the 6. All right. Next step is to take a square root on both sides. These cancel out. And when you take a square root, you don't want to forget that you do get a plus and a minus. Now, 16 is a nice square root. The square root of 16 is simply 4. So the next thing we're going to do is we're going to write two equations. We're going to have n minus 1 equals 4, and n minus 1 equals negative 4. And then we're just going to solve each one. So for that one, I get n equals 5. For that one, I get n equals negative 3. Now that's an example of one where we have a nice square root. Sometimes you don't get a nice square root, and that's what this next one is all about. So same first step, we're going to get rid of the outside numbers, which means we're going to start by adding the 119 on both sides. Next step is to take a square root. And we still get a plus and a minus. And now here's where things get a little bit different, though. because we don't have a nice square root for 124. So when that happens, we have to break down the number. I'm going to switch colors here. So what times what makes 124? Well, you can just keep dividing numbers until you find one that works, but I can see that that's an even number, so I know that 2 can go in there. So if I divide 124 by 2, I get 62. It's still an even number, so I could break that down also. 2 goes into 62 31 times. So we broke apart the 124, we broke apart the 62, and we're left with these 3 numbers that don't simplify anymore. So as a square root then, we can rewrite that like this. And since we have a pair of 2's, I can take that pair out and write it as a single 2 on the outside. And that's what I'm going to replace this with now. I'm going to replace the 124 with 2 square root 31. The last step is to write 2 equations. One where you have x plus 10 is equal to a positive 2 root 3. And one where you have x plus 10 is equal to a negative 2 root 3. And for both of them, we're just going to subtract this 10 over to the other side. Now, you can't actually combine the 10 with that 2 root 3 because that's a square root and they don't combine. So we'll just write them as 2 separate numbers. We have negative 10 plus 2 root 3 and negative 10 minus 2 root 3. And there we have it. So it's a weird answer, but that's the answer. So sometimes you don't have nice square roots. One more example like that. You'll see what's interesting about this as we work through it. All right, so step 1 is to minus the 59 both sides, because once again, we want to get rid of those outside numbers. Next step is to take a square root. Now, we get a plus and a minus square root of negative 63. Once again, we're going to break it down. But we have an interesting situation here. I've got a negative. You guys may recall that when you have a negative, you're going to take the negative out of the root and replace it with an I on the outside. After that, you're going to break down your 63. So the 63 broke apart into 9 and 7. The 9 broke apart into 3 and 3. So we're left with 2 3s and a 7. I can take a 3 out. And that's really the only difference I wanted you guys to see, is that you can get an imaginary answer there. So we have x minus 1 is equal to plus and minus 3i root 7. We're going to write that as 2 separate equations. And then we're going to add 1 on both sides. Gives me x equals 1 plus 3i root 7. That's one of my answers. And for that one, we're going to get x equals 1 minus 3i root 7. And there you guys go. Those are your 2 answers. All right. Number 18 is asking us to find the roots. Roots are also known as x-intercepts or zeros, so it could be asked in different ways. So how do you find the roots? Well, the roots are where it touches the x-axis. So like, let's say it was touching here and here. Well, what roots have in common is the fact that their y value is always 0. And we want to find the x value that goes with that. So the way that we do this is we're going to plug 0 in for y and solve for x. All right, so let's begin. Minus the 66 on both sides. divide by 3. Square root. We got to work on that square root a little bit. There's not much work to do with it. First of all, we are going to take an I out because it's imaginary. Second of all, if you were to break down 22, you just get 2 and 11. Now, since there's no pairs, we're just going to leave it like this. Put those back together. So what we have then right now is x minus 2 is equal to positive I root 22, and x minus 2 is going to be equal to a negative I root 22. I'm going to add 2 for both of these equations here. And we get 2 plus I root 22. And we get x equals 2 minus I root 22. Now just so you guys know, this is the roots. This is where it touches the x-axis. And since this is an imaginary number, that means that it doesn't touch the x-axis. The parabola does not intersect the x-axis. So it would probably look something like this, for instance, where it's above the x-axis and it keeps going up. All right. Use the information provided to write the vertex form of the parabola. So now, this is the opposite of a problem we did earlier. Earlier, we started with vertex form and changed it into standard. This is opposite. We're starting with standard, and we want to change it into vertex form. Okay, so let's begin. The first thing that we're going to do is we're going to add the c on both sides. The next thing we're going to do is factor out the a. Notice how that becomes plus 6x because you're dividing the negative 18 by a negative 3 when you factor it out like that. The next thing we're going to do is we're going to complete the square. That means we're going to add a new number in here. The way that you find that number is by taking half of 6, which is 3, and then squaring it, or raising it to the second power, in other words. So 3 squared, and that's 9. And that creates what's known as a perfect square trinomial. Now, since I added something on the right side, my next step is to fix the balance of my equation by adding something to the other side as well. Here's how that works. We're going to multiply the 3 times the negative 9, and whatever we get there, that's what we're going to put here. So 3 times negative 9 is negative 3 times 9 is negative 27. All right, from there we're going to simplify. So we're going to add the 20 and the negative 27 together to get 7, negative 7 that is. And on this side we're going to factor. It's supposed to be a square there. When you factor a perfect square trinomial, it always looks like this. All we have to do is find out what this number is. And that number will always be half of that middle number, so it's going to be plus 3. The last step to get it into vertex form is to add this 7 back over to the other side. And we're good to go. Once again, this equation is the same thing as this equation. They're just in different forms. Why do we do that? Well, sometimes it's easier to work with a function in one form than it is the other. And so it's good to be able to transition from one form to the other. All right, so for the last one, I'm going to do 21 and 22. I'll leave 23 and 24 for you. All right, so the last one here is a word problem. All right, So the problem is telling us that a ball is thrown from an initial height of 3 feet. They tell us that after it's traveled a distance of 12 feet, it's reached its maximum height of 6 feet. Okay, so what we have then here is we have a parabola where the vertex is 6, 12. I'm sorry, that's backwards actually. It's 12, 6. The x value is 12. The height is 6. And we have the starting point, which is an x value of 0 and a y value of 3. Okay? So basically the numbers that I give you will represent the y-intercept and the vertex of a parabola. And we want to write the equation of this parabola, and we've done that already on this study guide. Unfortunately, with the word problems, the equations will come out a little bit uglier, though. But nevertheless, the process is the same. The process is, this is an x, this is a y, this is the h, and this is the k. And we're going to plug those in first. And then we're going to solve for a second. Zero take away 12 is negative 12. Negative 12 squared is 144. Then we just solve for a. So we have a is equal to 9 over 144. And I think I made a little boo-boo. This was, let me back up a little bit. I made a mistake. Sorry about that. Just realized this is a plus 6. All right, so I should have subtracted 6 is what I should have done there, which means we get negative 3 over there. And we have a equals negative 3 over 144. Once you have a, you're going to plug in your h and k, as well as the a value, into your equation here, and you'll have your equation. Okay, so there's a quadratic function that models this scenario. It just has an uglier looking a value, but we've already done that once today. I think the trick is making sure you know how to turn these words up here into a picture with points. And just making sure you know that one of them is a vertex and one of them is your starting point. All right, let's move on to number 22. What will be the ball's total horizontal distance by the time it lands on the ground? So in other words, we had this picture, right? We threw a ball, and I want to know how far will it have gone? What is this distance? Okay, now basically what that is that's a root. That's where the y value is 0, and I want to know what's the x value that goes there. How do you find a root? Well, you're going to plug 0 in for y to your equation. So my equation was y equals negative 3 over 144 x minus 12 squared plus 6. So I'm going to be replacing the y with 0 because that's the height it will be at when it lands on the ground. So now we get to solve this. Step 1 is to subtract 6 on both sides. This next step is the one that's kind of a bit of a pain in the butt for the word problems because we've got a fraction here. What we're going to do is we're going to get rid of that negative 3 over 144 by multiplying the reciprocal on both sides of the equation. Okay. On this side, they cancel out, so that's nice. That's what we're going for. It's just going to be x minus 12. On this side over here, I would say just get your calculator out and do it. So we're going to do the two top numbers multiplied together first. 144 times negative 6. And that's negative 864. And then 3 times negative 3 times 1 is negative 3. And then you're going to divide these. Do the top number divided by the bottom number on your calculator once again. I just so happen to get a nice answer. It's still big, but it's not a decimal. But it doesn't really matter because we're letting the calculator do all the work. So just go ahead and put your answer there. The next step is to take a square root on both sides. And once again, we're not going to do those square roots by hand for this problem. We're going to let the calculator do it for us, just because it's typically these are just going to come out to be really ugly answers. So I'm going to square root both sides. Now typically you get a plus and a minus when you do this, but in this word problem, we're only going to go with the positive one. That's the point on the right side of the parabola. That's where it hits the ground over here. We don't care about where it touches over here, the rest of the parabola, so I don't care about that. We only want the right side, so we're only going to look at the positive version of the 288. But once again, using my calculator, I'm just going to find the square root of 288, which is 16.97. Now I think it's safe to go ahead and just round that to the nearest whole number, which is 17. I'm going to add 12 on both sides, and we'll say about 29 feet. So I am asking guys to round just because we don't need to get that precise. So long as we're close, it's good enough. But there it is. So the ball would be about 29 feet away from where it was originally thrown. All right? And I'll leave the rest to you guys. Hopefully that was helpful, and we'll see you guys next time.